Welcome. Today we'll solve a small ratio on the request of GR, that is a voltage. A voltage V out is represented as a ratio of two complex numbers, where the complex numbers, both of them, are in rectangular form. We want to solve this ratio, but we already know this, and this ratio was taken from lecture CA26. Right. We already know that the ratio is easier to solve if the two complex numbers are in their polar forms. But here we have the two numbers in rectangular forms. So the first thing that we are supposed to do is to convert them into polar form first. So to convert this number in numerator in polar form, we'll write r, and we know that r r is written as the square root of x squared plus y squared. Oh, it's very hard to write it this pen. So, and theta is inverse tan of y over x. Right. So we convert this upper number into polar form. The r is square root of 24 plus square root of 4 and the whole square root at an angle of inverse tan of 4 over 24, where 4 is this y and 24 is x. Similarly, we converted this lower number, the number in denominator, in its polar form, and this 24 squared is this 576 plus 4 squared is 16, and we solve it unless we reach here at this point, where this is square root of 592 divided by square root of 5. Square root of 592 is 24.33, square root of 5 is 2.23. So at this point we are supposed to divide magnitudes, but do not divide angles. Subtract angles. This is very important. So divide these magnitudes. 24.33 divided by 2.23 yields 10.91. At an angle of 9.48 is minus 26.56 taken in the numerator becomes plus. So this is very important. This minus angle becomes plus when we take it to the numerator. And then we add these two angles, this becomes 10.91 at an angle of 36.04. I hope this small lecture will help you understand some basics of complex numbers, and we come across complex numbers very frequently when we solve AC circuits. Thank you.